Welcome again and thank you for joining our global webinar day here at Infosim. Our topic today is Robots as a Service, Smart Industrial Manufacturing. My name is Hendrik Degener, Sales Engineer with Infosim, and I will be moderating this event. Today I'm very excited to announce that we have 4 guest speakers from the award-winning Catalyst team of this year's TM Forum Live. I will not introduce them all now, but I will introduce them when they are about to speak. The first topic in our rich agenda is why Industry 4.0 smart manufacturing will enable mass customization and revolutionize the market. It is presented by Darren Williams, joining us from his office in the UK. He has worked for TWI for just over a year now and is the lead for the Welding system integration team. The WSI team work across a variety of manufacturing sectors to provide solutions to digital manufacturing challenges with innovative projects, alongside defining and leading TWI's digital automation strategy. Prior to his role at TWI, he worked for Rolls-Royce, where he aided in the setup and implementation of a brand new state-of-the-art automated production facility. Darren is a chartered engineer with a doctorate from the University of Bath in Systems Engineering and a master's degree from the University of Sheffield in Automatic Control and Systems Engineering. So, good afternoon to you, Darren, and welcome to a Global Webinar Day.
Hi, thank you very much for the introduction. Good afternoon, everybody.
All right. However, before I hand things over to Darren, I have a couple of items to announce. First off, all of you are automatically muted to keep down the background noise. So to answer your questions, we will use the questions window of the GoToWebinar application. As usual, we will be taking care of all your questions either directly in the chat or at the end of today's webinar in our question and answer session. So please don't hold back and let us know if you have a question or remark at any time. Also, please be aware that this event is being recorded and all of you will be notified tomorrow via email on how to access that recording. And that's all from my end so far, so I would like to go ahead and hand over control to our first presenter and guest speaker, Darren Williams from TWI. Darren, are you ready to start?
Yes, thank you very much. Hi, so good afternoon, everybody. My name is Darren Williams. Thank you very much for the introduction. So I work for TWI, the Welding Institute, and we are world leading in the RTO, Research and Technology Organization for Welding, Joining and Structural Integrity. So we have a number of sites across the UK with our headquarters in Cambridge and 4 other satellite technology centres placed around the UK as well. We also focus on delivering training to various levels across the UK. So we deliver training to apprenticeships all the way through to PhD levels in welding, structural integrity principles with a number of accredited courses. We have a turnover in excess of 80 million. We currently have just over 700 industrial members who are based worldwide. So with regards to our smart manufacturing demonstration, we've pinpointed a few examples here. So we've got an example of a single cell, which is on the left. This is typical to research and development environments where you'd have one robot where a programmer tends to, as you can see in the picture, program the cell to do the process. And then you've got production lines where there may be multiple programmers capable of programming the whole production line, but there's a lot more robotics and automation held within the line. So looking at Industry 4.0, this is the latest industrial revolution. Focused within manufacturing, we can see that over the years a number of industrial revolutions have taken place. The first industrial revolution was focused on steam and water driven mechanical production systems, and this started in the 18th century. It was pioneered by the UK. Across the UK there's a number of centres where we mass produced cloth. Then the second industrial revolution that focused on mass production again, but using electrical driven conveyors. The third combined PLCs. So for example, Siemens pioneered the first PLCs to embed IT into the industry. And now the fourth industrial revolution is focused on cyber physical systems. So the cyber physical system would be the virtualization of your physical system into the virtual world. So you've got your models which interlink back to the hardware via a number of sensors. Via the Internet of Things, you can capture the data in real time to provide analytics and self-healing on various processes. And given that data, there's a lot of data, so there's a term called big data, which just signifies the amount of data that's generated through these physical systems. Okay, so Industry 4.0 within manufacturing, it enables organization, communication and control across the entire value chain. So from idea to order, from deployment into production, then to delivery to the customer. And it doesn't just stop there, it goes after the delivery in providing a service to the customer so that they're always getting the best use out of the product. These products are now individualized, so customized on a per requirements basis. And there's a number of key research elements within the manufacturing field. So we've got horizontal integration, so via network to network, end-to-end engineering, so across the whole value chain, and vertical integration on the shop floor for networked production systems. And here we've got a slide on the commercial value add for our project. The graph on the left shows the robot density, which signifies the number of robots per 10,000 employees. And if we just look at the UK there, we've got 31 per 10,000 employees. Calculating through a few numbers, so we've got 2.6 million people employed in manufacturing in the UK, equating to around 8,000 robots. So bearing in mind this is ignoring the automotive sector for now. So facilitating mass customization on these robots. Typically, a robot cell would require 8 to 10 reconfiguration activities per year. So this involves a certain amount of downtime, certain amount of labour required. I've estimated this around 250,000 per year. So over the UK manufacturing space, there's a potential cost saving of 200 million just for the UK, when we start to facilitate mass customization. So therefore we're focusing on reducing the amount of machine downtime, going from a series of days to a number of hours, not minutes in some cases, and as well reducing the amount of labour requirements. So the vision for digital manufacturing is, from the slide I showed at the start, where we've got just one cell, so the multiple cells placed within a factory, and then factories worldwide would have the cells interlinked together with smart materials going into the manufacturing process and smart products coming out. We will facilitate a whole ecosystem of smart manufacturing, giving us a self-determinate system, a set of systems where we've got systems which are able to determine their own field of activity, wireless independent communication, so systems able to communicate with each other, self-optimization, systems can be configured given the customer's requirements, product requirements, automated resource management, resource can be aligned between the various cells as efficient as possible, and human collaboration, so the humans as well are working with automation. Okay, so just to give an overview of the architecture, we'd have a cell, a robot cell there, and this would be virtualized by what we've termed a domain controller. So that would show a simulation of the cell. The simulation would be connected to a communication layer which would facilitate the connection of APIs, and then we can have a number of APIs connected to that, such as supplier ordering systems, fault configuration, management systems, performance management systems as well, and so on. We can also have business support systems connected to that, which would facilitate the user as an entry point for the user to submit CAD models, product definition data to drive down the manufacturing process. Today we've got a robot, which has now become a service. We've also got a factory as a service, and ultimately we've enabled manufacturing as a service. This whole architecture does play on the various elements of Industry 4.0. So we've got the interoperability, where the customer is linking right to the hardware via the Internet of Things. We've got virtualization and decentralization, so the creation of a cyber physical system where we've modeled the hardware and got a virtual system. Decentralization is where the virtual system can control or feedback to the actual hardware. Modularity, so here we've got a number of modules which are plug and play. You can adapt these with minimal time and effort. And you've also got a service orientation, so the service is right at the heart, from the heart of the customer. That's all from me. Real-time capabilities as well, sorry, I've missed that one. So we've got real-time capabilities to get data and act on that data from the system. Okay, thank you very much. I'll hand over to our next presenter.
Thank you very much, Darren, for your presentation. Now we will deal with another interesting matter. It's how the manufacturing companies embarking on a digital transformation strategy can leverage assets such as open APIs. Joann O'Brien from TM Forum will tell us more about it. Her career spans over 20 years in technology, ranging from consumer electronics and telecommunications, mobile switching to OSS, BSS, and more recently to industry collaboration. Joann currently leads a number of new strategic initiatives within TM Forum, including the Open Hack program, as well as incubator initiatives exploring ICT for climate and industrial manufacturing. She has significant experience leading complex, large-scale transformation programs for a number of organizations and has a mixture of technical management background. She has a Bachelor of Science in Information Technology, majoring in telecommunications from Dublin City University, and an MBA from Open University. Joann is entrepreneurial in nature and is innovative in bringing together companies to collaborate and create a new infrastructure for the future. She particularly enjoys working across different technology disciplines and believes in sustainable technology for good. So, enough said from my side. Good afternoon to you, Joann, and welcome to a Global Webinar Day.
Hi, Hendrik. Nice to meet you. Hello, everybody. So thanks, Darren, for that introduction. I just want to add some additional points to the context. So really what we're talking about with this project is bringing together some problem scenarios from the industrial manufacturing space, which Darren outlined, and bringing concepts and tools that we have created as part of our digital initiative within TM Forum over a number of years. So the project started as a collaboration between TWI and TM Forum, as we started to investigate how we can merge the technology evolutions between our industries and how we can learn from each other and explore from each other as well. And that was kind of the seed from which the project came. And really what ultimately is going on in the industry is that all companies are looking at becoming a digital leadership. There's a lot of direct correlation between your digital success and your financial success of your organization. All companies are looking at creating new services, opening up new markets, tightening partnerships, and it's through these APIs and these partnership capabilities that these new opportunities are coming into play. So essentially, you know, the boundaries between industry verticals is dissolving, and this project is a great example of that. How, you know, we hear of the word ecosystem being used an awful lot, but it really is the case in this space where we are looking at bringing together insights from telecommunications with industrial manufacturing and looking to optimize these technologies in a particular scenario. And Darren has shown that, not only can we learn from each other as industries, but we can actually make significant financial savings as well. So becoming a digital business is a complex thing, right? And you don't really want to be trying to solve that on your own as a company. You can choose, however. But for the most part, we believe there's an awful lot that companies can learn from each other, which is why within TMForum, we work collaboratively across the industry to share best practices, learn how to plot and map through this digital architecture transformation for lots of different companies. The programs we run are Open Digital, Internet of Everything, and Open APIs, just to name a couple to give you an example. So who is TMForum? We are a not-for-profit industry association. We're a membership-driven organization, and we build collaboratively these assets for the industry. From an API perspective, all of the APIs that we are talking about today are available freely to the public, not just to all our members, but to everybody who wishes to access them. Okay, and it's, to get a sense of the strategic opportunity that APIs open up for a business, I think a great example in the last week is Twilio. So Twilio, like last Friday, was worth $1 billion on the morning, and by Friday evening was worth $9.4 billion because of the flotation in the stock exchange, the New York Stock Exchange. Twilio started out just a short number of years ago looking to solve the problem of connecting two discrete things and providing a common API to expose SMS capabilities across the globe. And they solved that problem, and through that created a new marketplace. So this is a shining example of how you can think of APIs as becoming strategically valuable to you as an organization, how you can expose capabilities, and particularly if you use common APIs that are adopted across the globe, how you can get that portability across the globe as well. So that just gives you a flavor of who we are. And then moving to the next slide, a little bit about the project itself. So the project itself, if we can go back one slide, because I think we're both maneuvering here. The project itself, as I mentioned, we started out looking to solve the problem of reducing downtime, taking a simple, clearly defined scenario, reducing downtime on robots. And but it's not just about, an important point for us to kind of call out here is it's not just about improved automation. I mean, obviously the manufacturing industry is extremely agile and extremely lean and highly automated across many aspects already, but this is about laying a foundation for what we call the Industry 4.0, which is fundamentally about creating agility into the business, laying a foundation for improved decision making. So a lot of the real-time data that can be garnered in an IoT type system enables what we call context-based decision making. So basically automated decisions which occur much more rapidly, much more frequently, and are much more accurate based on real information at a given point in time. And the APIs that we particularly focused on for this project were the product catalog, activation configuration, performance management, etc. And the guys are going to show a demonstration of that just shortly. So then on the last slide, what we show here is, the point I'm getting across here is that it's not just about APIs. APIs are obviously the window or the digital pattern that allows the machines and software to communicate with each other. However, there is an awful lot more thought process behind all of these APIs. TMForum has a whole suite of libraries called what we call frameworks, and thanks to John Williams of TMForum and Cliff Hoya of EnterpriseWeb, created a detailed mapping. And this can be made available to anyone if you wish to contact afterwards, where we identify the mapping between all the process components of the frameworks and the actual processes that were underway within this particular project. So providing a much more in-depth tool of mapping, so you can start to see how it can change not just the interface or the integration point, but also the end-to-end processes. So it's just another flavor on the project and the intelligence we're attempting to build up to share to the industry. That's it for me, really. Okay.
Thank you, Joann. I think we are now all ready for a live demonstration, which is done as part of the presentation of the following topic. It's how the use of dynamic APIs enables industrial ecosystems without any code or manual integration. William Malyk will be the person in charge. William, also known as Bill, is a PhD candidate in the David R. Cheriton School of Computer Science at the University of Waterloo with a focus on generative programming. He has a Master of Mathematics from the University of Waterloo and a bachelor degree in science from Wilfrid Laurier University. He developed the enterprise web platform from the ground up and is responsible for implementing the company's technology roadmap. Bill is an inventor on the company's 2 awarded patents and is a co-author on several academic articles. Good morning, good afternoon to you, Bill, and welcome to a Global Webinar Day.
Good afternoon, everybody. I'm happy to be here. So I'm going to start out with a very brief introduction of Enterprise Web. We were one of the participants in this catalyst, and what we were used for is providing a fabric that could connect the partners and be used to model basically the manufacturing domain per the Industry 4.0 sort of concepts that you've already seen introduced earlier in the presentation. So what we are as Enterprise Web is an application platform where we provide a one-stop shop, or basically an end-to-end sort of solution for the unified management of model-driven applications across many different domains, including IoT, cloud, etc. Part of that flexibility means that we can bring in everything from the sort of cyber-physical systems that we talked about earlier in the presentation, so connecting these robots or devices or machines together, or on the other side completely software-driven applications, so connecting web services, for instance, and analytic pipelines and everything sort of in between. And basically our design environment lets you rapidly prototype these things. So you're getting cloud-native applications that are parallel, distributed, asynchronous, stateful, multi-tenant, version controlled, the kind of properties that you want and normally are delivered by thick stacks, many different components. We bring those all into a very simple, easy to distribute runtime environment that's basically just there to connect the wires, if you want, between each of your partner assets, do it very flexibly fast without ever having to hard code it or sort of write your traditional low-level code. So if we're looking at the smart industrial manufacturing itself, oops, sorry, the slides are going a little quick for me. The smart industrial manufacturing. So in this particular catalyst, we wanted to apply things to connect an ecosystem around manufacturing or the industrial manufacturing space. Enterprise Web on TM Forum catalysts had been an award-winning participant for connecting things in the virtualization space, so network function virtualization, standing up things like dynamic networks for the telecoms. And really in this catalyst what we wanted to do is bring those same kind of concepts that had already been applied, modify the existing standards of the forum to meet this new space. So in the catalyst we represent the universal interface, which abstracts all the technical complexity of connecting to these components. So what you're going to see is a declarative or intent-based model, which I'll go through a very simple demonstration of in a minute. But what you're going to find is that we're not writing things at low-level code. We're instead describing things very high-level, what a process should do, rather than how it should do it. And then we're allowing the system to basically find and bind or connect all of the actors. So to connect the Infosim monitoring and alerting type, in this case, capabilities that they're bringing to the project, and connect an ecosystem of the robot cells down below and anything in between. So pulling simulation from connected components, looking at things like connected supply chain. We do all of that in a declarative way. What this looks like, just from a high-level solution architecture, is that you get a horizontal, flexible, extensible, adaptable framework. You're seeing on the right a set of objects that basically represent endpoints. You're going to see a couple of those inside the project, but the whole point is that we make it easy for a developer to come in, describe the models of those things, including the partners. So describing an interface that Infosim might use and describing it in terms of forum APIs, so that we can very easily start to craft, what should happen when we receive, say, a ticket that there's been a problem within one of the robot cells. Well, we can craft that very easily within our system, and we do that using a set of platform-based services, right? So you get common architecture, universal interface, but moreover, you get shared tools and services you can reuse. So we make it easy for these partners to connect. And then finally, just a little bit of housekeeping in terms of the project. What we were really brought on to do in this catalyst was to help deliver sort of 3 high-level benefits: the DevOps automation, service velocity, business agility. Basically, if you want to think of it, DevOps automation, you're never going to see us write the low-level things you think of in terms of DevOps: Chef, Puppet, Python, Ansible. You hear a whole ton of different components that are out there. Well, we really abstract that and take it to a bit of a higher level, so you're not, basically this isn't going to look like something that you have to have an admin or DevOps user creating. Instead, it's going to be something that can really be in the hands of the domain expert. And then everything else sort of flows from that. Service velocity, we were able to design, test, and deploy this thing. When we say, service is down to minutes, that's from things that used to take, weeks and months to create in, traditional programming languages. We've made it something you can really realize almost immediately, and that gives you business agility. So you can be testing, expanding, changing these applications. And underneath it all, what makes possible to do this is, leveraging standards from TMF dynamic API, or sorry, TMF set of REST digital APIs, some of which Joann had already mentioned, and we do it dynamically. So we bring a spin to it where, basically you're bringing on information from your connected partner. So nobody specifies that, they're low level. This is going to be the set of attributes and variables and so on you get from my API. Instead, we sort of discover it. You connect to our system, we pull in the relevant information, make it easy for you to map to that. So I'm going to launch into a presentation here. Give me a moment to switch my screen. If someone on the call could verify they can see my screen.
Yep.
We can see you.
Awesome. Excellent. So what we're looking at right now is the modeling environment for enterprise web. Without getting into low-level detail, it lets you work from everything at an IT level, like I would like to set up, say, universal backup or disaster recovery for my entire application. I can start working at that level. I can talk about things like universal security policies. I want to connect against all of my connected partners in this kind of a case. We're just going to jump right to a couple of things that show you the real power of the, in this case, the domain models and so on, which is that we wanted to create an application for a space, a domain of industrial manufacturing, and then we wanted to create some processes against them for the demo that I'll show you in a minute. So this is sort of my development view. It becomes very easy for me to come in and start working with basically ontologies. And if you were familiar with the sort of cloud virtualization space, a lot of these concepts that you see in this concept map would be familiar. The idea that people place orders for products in this kind of a case, there's a little difference that we're connecting to robot cells, but there's no difference between connecting to a server. They have things like key performance values coming out of them, things like fault conditions that might be connected and so on. And basically the one thing that you find here is that we're reusing domain models. We're representing things very high level in a mapping world. And if you look at it a little bit deeper down, what you'd find is that, well, this is just mapped to a set of URIs where I'm going to be grabbing information about the robot cells, collect them in catalogs and so on. So we'll see the power of that in a second. And really what that power is, let me just zoom out a little so it's not going to be too hard to see, is that when someone's now coming in and using this, this domain model with all its connected assets behind it, all they really have to do now is describe what it is they want to do. So a process for literally placing a product order ends up being something that we just describe generally the tasks that we want to be carrying out when we do that product order. So somebody's going to come in and get a user interface, and we could literally move, you can see a drag and drop, move that task around to anywhere inside the process that we want. They're going to create a simple form, and then what we're going to have is a series of analytics, or basically a little pipeline that's going to analyze that. We'll have some optimization, including determining whether or not this thing can be manufactured, and eventually actually configuring the cells. And the nice thing here is that for any of these elements, when we describe them, we can just drill in. So what does it mean to get supply chain estimates? Well, in the declarative sort of spirit, when I look at that, again, I'm not writing code, I'm just describing where to get this information, and again, without ever writing a low-level integration or any kind of sort of, I don't know, how would you say, operator level or programmer level of description. Instead, I come in and I literally say, well, I want to get something out of the smart manufacturing space. What methods are available to me? And all of this comes from the underlying system. So I could import some analysis. I could modify catalogs. I could update orders and so on. I can describe that I want to import some analysis. What are the sources? Well, what if I wanted to grab something out of the materials catalog? do that very easily here. I could change it to materials catalog and I'd see what algorithms. There's ability to cost materials, there's ability to look at the supply chain. If I look at the robot cells, well, there's lead time analysis and so on. And literally all I'm doing is going through and describing what that sort of factor is supposed to be, and then any post conditions after. Well, in certain situations I may want to do something next, right? After a certain type of analysis, I may want to take a different path. So it makes it very easy for me to describe this in sort of little dynamic chunks. And then when it comes to the sort of payoff, which I'll show you right now, is that a customer logging in isn't really aware of any of this. The benefits for the actual, the person who's supplying this are pretty immense. I mean, they create this process within a couple of seconds. From the end user perspective, they get these dynamic catalogs that sort of flow right through to all connected partners. Here we see basically a catalog of the cells that are connected. These are real live integrated components, even including things like a fault condition, and David will tell you a little bit more about how Infosim did that. But basically around this cell, we have something that's actually monitoring its performance, sending out analytics to Infosim and receiving things like a ticket that will actually tell you that there's a fault, and then we can use that sort of round-trip analysis in our, again, within our sort of ordering process. So we can say, well, ignore this cell, basically do not place an order here. We can know that preemptively, rather than the old world where we placed an order without any real visibility in the underlying cells. We're basically connecting up those endpoints. So the other side of it is that if I place an order, what I get is literally real time, and this is connecting thousands of different analysis points really in one simple interface. If I wanted to place that order, this is mass customization realized. So I'm going to say my order new part, and then right from the get-go, I'm uploading a CAD model. Whatever CAD model will be connected to some kind of simulation capability. Here it literally renders it. This is what it's going to look like based on that CAD model. I can pick my materials from a connected catalog which has supply chain and all that other stuff and costing around it. So I'm going to say I want this in titanium, I want 3 of these, and then I'm going to say that, hey, I've got 12 hours to produce it, right? And what it's going to do in real time is run through those, all of the different robot cells, all the different materials, what the supply chains are connected, all that good stuff. Using that process you saw me make very simply there, and it'll give me analysis like telling me there's not enough stock. Well, okay, I've got a supply chain problem, I've got to order, it'll take longer. Where's the best cell? So again, right fit. What can produce it for the cheapest? What can produce it in the quickest time frame? Giving me basically real-time sort of optimized placement of this order. So hey, I'll get it best or cheapest from a certain cell, and you can see that's done literally for every one of them. And you can see this is all real-time by, I changed it to something like aluminum, which is much cheaper. Well, I get a cheaper value. I go in and I say something like, well, I want to create this thing in 1 hour, and the system's going to realize, well, you know what, first there's not enough stock, there's a supply chain, but basically nothing can fill my constraints. So all of this, again, is something very simple, easy to create within the system, and can be effectively made as complex as your business process requires. So if you need 20 factors to be included here, it becomes very easy for you to extend it and sort of grow it as you go. So that's a quick look at the demo of the Catalyst, which won the Best New Catalyst Award at the TM Forum this last meeting. And back to you guys.
Thank you very much for this demonstration, Bill. And more live action is about to come. In the final topic, it's how the unified network and services management approach automates enterprise workflows and increases work efficiency. The panelist is Dr. David Hock, joining us from our headquarter office here in Würzburg, Germany. He is an R&D senior consultant at Infosim, where he's coordinating the research activities, in particular in the areas of SDN, NFV, and IoT. Prior to Infosim, Dr. Hock was working as a research assistant at the chair of communication networks at the Institute of Computer Science in Würzburg, where he finished his degree in 2014. He's an author of numerous academic papers, articles, and proof of concept demonstrations. So good afternoon to you, David, and welcome to a Global Webinar Day.
Good afternoon, everybody. Thank you, Hendrik, for the introduction. So it's a pleasure for me to show you the second part of the live demo that actually won the Best New Catalyst Award in Nice this year. I very briefly want to start with one slide for those in the audience that are not familiar with Infosim and StableNet yet. So a very brief introduction to who we are and what we do. Actually, Infosim is selling StableNet, implementing and selling StableNet, a third-generation unified management tool. The particular special thing about StableNet is that it includes all the different parts, starting from configuration management, fault and management, and automated root cause analysis, and performance management in one single tool. So with our solution, you can do all configuration parts like automated backups, restorations, policy checkings, vulnerability checks, configurations of devices, but you can also look at faults of the system. This can be faults in a telco environment, this can equally be faults in an enterprise environment, in an IT infrastructure, but this can also be, as we will see in the live demo, this can be faults in a robot cell environment. And finally, there is also the performance management part where you can monitor all the information, you can do reports, you can use the information for further sort of analysis. We do that typically for servers, cloud and networks, but also for higher level, on a higher level for applications or for processes. And in this catalyst we could actually show that we can also use the same approach for robot cells in the smart industrial manufacturing area. So getting back to the drawing that Darren had already shown before, actually the main role that we took in this catalyst is on the fault and performance management part here in the lower right corner. And now I will actually directly switch to our software StableNet to show you a short live demo on what functionality we could leverage in the catalyst. So first of all, here you see our StableNet Rich Client GUI based on Java, where we actually start with an overview picture that shows a dashboard overview on the robot cells that we looked at during our catalyst. So in this case, for the demonstration, we decided to put robots to 4 different locations on the world. We took the 4 locations of the headquarters of the participating companies. And then we decided to have 2 different types of robots, and here you can see for each of the robot types at each location you have active robots, those are the green ones, you have idle robots that are currently not sending any data, and you might also have robots that are on error. This is actually the first place where we used the forum APIs. We are getting this data from the TMForum performance API. And now if we look at this one cell that is actually currently on error, we can right-click it and we can, for instance, jump to the device view, and this will lead us to a different view inside StableNet. Same product, just another view where we can actually see more information about the robot cell, and we can, here for instance, we can see all the different metrics that are gathered for the device, for the cell using the forum APIs. And if we jump even further to the measurements, what we call a measurement in StableNet, we can then get more information about all the different metrics, and we can also open an analyzer that will actually show us here, in this case for the last 3 hours, the average values over 15 minutes for the different metrics that we are gathering. So right now we see all the 9 metrics, but maybe we want to focus only on the, let's say, maximum voltage, so we can only select that one, and we can actually see it here and zoom a bit more into the values. We can also create a link that then can then be opened in a browser, so you can, for instance, share this with your management, or you can also scan the QR code to take it with your StableNet mobile app to have it on your smartphone. Then I want to move to the StableNet web portal, which is actually a web-based view. So you see this is like running in a Firefox browser. This is a web-based view of StableNet where you have the possibility to interact with the network management system using a normal web browser. Here again we see the overview dashboard, and if you click at one of those devices, you can here again see more information about, oh, that was just during the reloading step. Here it is. So here we see more information about the metrics that are covered, similar to what you have just seen in the Rich client. And if we move to another view, here to the status geomap view, you can actually also see that here we have the different statuses of the robot cells on a geographical map with OpenStreetMap, and we can actually zoom in and look a bit more in detail. So here in this case, for the demonstration we had at Nice, we actually placed some of those robots in Nice at the location where the show took place, and if I click here I can also see that the 12 robot cells in Nice, 9 of them are okay, so they are running actively, 2 of them produce no data with the performance API, so they are inactive, and 1 of them is in a minor alarm state. The second use of the API we made that I did not explicitly show here is that once we have an alarm when a threshold is exceeded, we actually use the TMForum ticket API to create a ticket that was then interpreted automatically by EnterpriseWeb to update the states of the robots and to know that this machine can currently not be used for production. Now I jump back to my slides just to show one more slide, as I cannot really give a live demo of the StableNet mobile app here in the webinar. This would take too long. So just some screenshots in the mobile app that runs on Android or iPhone as well. You can actually see the currently open alarms. You can look in more detail where the alarm is located and get directions for the navigation system to drive there. You can again have the dashboards that you saw before also on your mobile device if you scan the QR codes. So in this case, this is not a still picture, but this is a picture that is refreshing from time to time so that you always have an up-to-date state. And you can also have not just the dashboards, but also the different charts on your mobile phone. That is all from my side. Thank you very much, and I'm handing back to our moderator, Hendrik.
Thank you very much, David. So, the presentations are done, and now we still have some time left to discuss some questions in more detail. The first question I want to address to Bill, it's how can distributed models be maintained semantically correct with weakly typed interfaces? A very interesting question from one of our attendees.
Yeah, that's actually a great question. We can almost have an entire webinar on that topic itself. The concept with the distributed models, so there's a lot to go into, but the way that we look at this in terms of semantics or semantic web and all of that is that that idea of a common information model that you might find between so the distributed piece coming into it, distributed endpoints, right? So we have multiple different actors who are going to be contributing here. We have some place like the TM Forum who's going to be providing some standards in the space, but they're not going to be the only ones providing standards. So you might have others from Etsy or the OMG or all the different kinds of groups. So you're really looking at a world that's going to have many of these standards. And when someone tries to impose a common information model, the normal kind of, if you want, semantic, how to say it, semantic solution in that space, the problem is going to be, of course, that that's really either computationally hard or it's just something that becomes almost impossible to maintain. So what we've done instead, and the concept of weakly typed interfaces, at least for anyone who's not quite aware, the idea is that with a weakly typed interface, you don't have something that's sort of locked in terms of what your object looks like. So its definition is something that's a little more flexible. So given that concept that we're going to be working with a whole bunch of different actors that might need flexible data types at each level, what we did was focus on this thing called the dynamic APIs, which is basically a, how would I say it, it's a model for how those weakly typed components would actually be interacting with each other. So it's a pattern for how these components can communicate to one another what their semantics are going to be. So to say it a little bit more simply, we attack the problem as something that's going to be negotiated between components that are going to work together. They're going to be basically looking up or using linked data type concepts to figure out how to work with one another, rather than trying to, across the board, impose one giant solution. And you can see more about this if you follow the links to dynamic APIs and so on, but it's a hot topic, I think, within ourselves and the TM Forum. A great question.
Okay, and a great answer, I think. Another question goes to Joann. It's if there are other examples where TM Forum proved the open APIs beyond telco. So Joann, can you hear me? Are you still there to answer this question? I see you are muted.
Can you hear me?
Yes.
Can you hear me? You can now.
Yes.
Before I jump into that particular question, just on the last question regarding the information models, so TMForum does work collaboratively with other organizations regarding information models. Everything Bill said is completely support, but that is an initiative that we continuously try to support, is alignment at least between these information models as much as possible. The next question regarding other areas where the APIs can be used, yeah, actually it's very interesting across a number of different industry verticals. We've been showcasing and validating these APIs in different sectors. So just taking, for example, the TMForum Live event most recently at Nice, we had a number of examples around digital insurance. We've had connected car capabilities in the past, using the APIs, and now a mature catalyst series in the e-health space where patients are monitored across their life, so regardless of their location, based on be in the home, they can be out in their car, they can be, you know, wherever shopping, and they use the APIs to be able to monitor the health of the patient in real time. So yeah, many other examples.
Okay, thank you, Joann. And the final question in this question and answer session, I want to first address to David. It's how much effort actually went into this project?
Oh, that's a good question. That is actually something that could also be asked to Bill, I guess, to the two of our participants. So actually, I would say from our side, it was rather a matter of hours and days than days and weeks to implement all that, because making use of the existing APIs that we have already in our product, combined with the clearly defined APIs that we got from forum side, working together with EnterpriseWeb, I really think that it was definitely a week of full-time work to set up all this. I'd even say like rather 3 to 4 days, so it was like really not that much effort. Curious what Bill is saying?
Oh yeah, I would echo exactly the same thing. I mean, the use of the APIs made it very, I don't want to say easy, but made it very straightforward to connect our various components. Before the Catalyst, neither Infosim nor EnterpriseWeb had worked together before, and we were able to, within the span of a week, and that mainly was communication, you know, getting the right endpoints communicated to one another and just registered within the systems, up and running. So it was very straightforward and easy, and all empowered by concepts like the dynamic APIs and the adoption of the digital REST APIs from the forum.
Okay, thanks you two guys, and yeah, thanks to all guest speakers for this interesting session. I would like to thank everyone for joining us today, and as I have mentioned earlier, a recording of this webinar will be made available to all of you tomorrow via email. I also want to mention that we have some handouts available in the handouts part of the Global Webinar application. Those are 5 PDFs, and you are very welcome to check them out. We will also keep the session open for a few more minutes in case anyone from our audience decides to type in another question. And I also want to mention the next Global Webinar Day in July 28th. You're very welcome to join there as well. So thanks everybody for joining us, and enjoy the rest of your day. Goodbye.